Hello, my name is Tarik Kucukdeniz. I am from Istanbul University Department of Industrial Engineering. This presentation is about our study on short-term wind speed forecasting. We used support vector regression and multivariable gray model, and we compared these two methods and analyzed the results on short-term wind speed. First of all, we should talk about wind energy, when and why wind energy is useful and important. If we say that wind is generally regarded as the most renewable and green type of energy, but its complex nature makes it very hard to predict, but we should make some predictions about the speed and the amount of the energy that we will take, electricity that we will take from the wind, because we need this forecasts to make our production scheduling or our bidding optimization or some kind of electricity businesses. Wind speed prediction is closely related to the power generation prediction. So generation and distribution planning requires accurate wind speed and power predictions. We can say that we need accurate wind speed and therefore power predictions. If you look to the literature about the wind speed forecasting methods, we will see that there are many applications. Also, there are some novel applications on wind speed forecasting. Generally, we can classify these methods as physical forecasting methods, statistical forecasting methods, and hybrid approaches. Physical methods usually consider physical conditions and physical properties of the wind and the atmosphere, like humidity, temperature, and pressure. And usually they do not use historical data, for example, wind speed data. But when we look at the statistical methods, we see that usually historical data, like past wind speed values, used with statistical and mathematical techniques. Heuristic methods, machine learning methods, fuzzy approaches, and conventional approaches like ARIMA or SARIMA can be mentioned under this heading. Also, when we deal about the wind speed forecasting, the data type is very important. For example, wind speed is an important input for the wind speed forecasting. Also, temperature data is also important. Besides them, air pressure, humidity, rainfall are all examples of physical data that we need in wind speed forecasting. Also, wind speed forecasting studies can be categorized under the time scale of predictions. In very short-term prediction, we are dealing with seconds to a few minutes ahead of wind speed forecasting. This information is important to sustain operational activities and real-time operations of the electricity market. Also, short-term forecasting means forecasting of the wind speed up to 2 days or 1 day. They are used in control of wind turbines, economic dispatch planning, unit commitment, and operational security of the market. So, market operators, especially market operators, need short-term wind speed forecasts up to 1, 2, or 3 days. Medium-term forecasting usually means up to 1 week. Is for operation and maintenance planning and management and optimizing the operating costs. So medium term is usually about the operator of the wind farm, for example, or the wind generator. They use medium term up to 1 week forecasts to maintain and to plan their operations. Also, long term means monthly, seasonal, or annual forecasts are especially important for power plant design and investment decisions. when one considers to make a wind power plant investment decision on a place, long-term wind speeds are the most important type of data that those persons should have or know or have calculated. In our study, we are dealing with short-term wind speed forecasting, and our main target is real-time markets and system operators. When we look at the literature, we will see that autoregressive moving averages or autoregressive integrated moving averages methods, neural network methods are usually studied in wind speed forecasting. Markov chains are studied. Some hybrid models that combine fuzzy and neural network approaches are worked or studied. When we look at today's studies, forecasting methods are very diversified. It can be easily said that researchers have preferred to use hybrid approaches, usually hybrid approaches for the wind speed forecasting to improve the prediction performance of the methods. Also, some important subject that we should talk about when we are dealing with forecasting is data preprocessing. For example, seasonal adjustments, wavelet transforms, signal decomposition algorithms, empirical mode decomposition algorithms are mostly or widely used data preprocessing methods. When we look at the gray forecasting methods in wind speed forecasting, there are only a few studies. Gray-related weighted combination was applied to monthly average wind speed data for monthly forecasts. In another study, gray relation analysis was proposed for analysis of daily wind speed series. And in this study, we can conclude that there is no study in literature in which machine learning and gray theory are used together to compare the results on short-term wind speed forecasting. In this study, we have used support vector regression. You may know support vector regression is a different version of support vector machines to make forecasts on time series objects or regression objects. Support vector machines is grounded on the framework of statistical learning theory, which was developed by Wapnick and Cherwonensky in 1974. Usually it deals with mapping the data in higher dimensions, so making a non-linear mapping to a linear mapping, then solving the linear regression problem, and then reapplying the dimensional structure to the data again. Also, in this study, we have used multivariable gray prediction model. Gray theory is extremely high mathematical analysis of the system that are partly known and partly unknown are defined as weak knowledge in gray theory, and insufficient data was first introduced by Zhu Long. Gray prediction is one of the most important parts in the gray theory. Gray prediction is a different type of prediction method based on the gray theory. Gray prediction models have been used in many problems. The GM1N model, which provides a good prediction using limited data, is the basic multivariable gray prediction model. The strong part or the strong property of the gray prediction is when we are dealing with limited data or there are some missing or weak points in the data, usually gray prediction models are very strong when we compare them with the other prediction methods. In GM1N, this indicates that n variable and one order gray forecasting. In this study, very short-term wind speed is forecasted. At each time period, legged wind speed data, month, hour, week number, minimum and maximum temperature data is used for training. Then this model is used to predict the wind speed of the next period. It's important to emphasize again that each period's wind speed is predicted by using the values up to the current point. So there is a rolling mechanism. For each period, we use the data that we have from the previous periods, and we use that data to make a prediction model, and we use that model to predict the next period's forecasts. So we can say that the training data grows to include the last period's data to improve the model training performance. To measure the performance of the proposed model to benchmark them against each other, we used root mean squared error and mean absolute percentage error metrics, as the formulas can be seen in the screen. And we compared those two approaches, I mean support vector regression and multivariable gray prediction, on an experimental study. Our data was obtained from Çukurova region of Turkey and was recorded in 15 minutes intervals between the years 2009 and 2011, and there was approximately 75,000 instances in the data. We didn't use all of this data to make forecasts. We had some we have some parameter selection. We have made some parameter selection on the data because in a regression model, some of the possible input variables may have more importance than the target estimation parameter. So for each variable, the increase in the prediction error if the values of the variable are permuted across the out-of-bag observations are computed on every tree. We used tree sampling for parameter selection. Then the average over the entire ensemble is calculated and divided by the standard deviation over the entire ensemble. So, for support vector regression, Gaussian kernel is selected. Also in the multivariable gray model with parameter optimization, the parameter values of genetic algorithm are as follows. The population size was 40, and you can see the crossover rate and the mutation rate. In gray prediction, we should make some parameter optimization because parameter optimization significantly improves the performance of the gray prediction model. For example, as you can see, the original GM1A model's prediction performance was 0.92 RMSE and its MAP was 63%. But we have applied genetic algorithm based optimization, parameter optimization on the GM model. So our prediction performance significantly increased. The numerical results show that the parameter optimization significantly increases the original GM's performance. This is our results on our experimental study. We can see the mean absolute percentage error of support vector regression and gray theory-based prediction model with parameter optimization. And as you can see, GM model is better in terms of forecasting error than the support vector regression model. So, in this paper, support vector regression and multivariable gray model are benchmarked on a large sample data for short-term wind speed forecasting. Among the many variables represented in the dataset, a predictor importance analysis is conducted and previous period's wind speed, minimum temperature, week number, hour and wind direction are selected as the model parameters. We have applied a chained cross-validation procedure and the results are reported. The results indicate that multivariable gray model with parameter optimization achieved better results than the support vector regression on the dataset. Thank you for your listening.